Good morning all. This is Satish Kumar, Assistant Professor of EC Department, SNS College of Technology. Now let us see the another video lecture series on linear time invariant system analysis using Z transform. First, we can see the difference equation. It is an efficient way to implement discrete time systems. The convolution of input sequence x of n and unit sample response h of n, it can gives the output as your y of n. Y of n is equal to summation k is equal to minus infinite to plus infinite x of k into h of n minus k. Two types of systems depending upon the length of the unit sample response h of k. That is FIR systems and IIR systems. FIR system is unit sample response or impulse response h of n has finite number of terms. Y of n is equal to summation k is equal to 0 to m minus 1 h of k into x of n minus k. Next is IIR systems. Length of the unit sample response or impulse response h of n is infinite. Y of n is equal to summation k is equal to 0 to infinite h of k into x of n minus k. Next one, we can see the recursive difference equation. Y of n is equal to y of n minus 1 into x of n minus 1 plus 0.5 into x of n. Input is nothing but your x of n, output is nothing but your y of n. X of n plotted with your 0.5 plus another term we are having which gives the output as your y of n. While we taking the z inverse of y of n, we can getting as y of n minus 1 that can be multiplied with your x of n minus 1. X of n multiplied with your z inverse, we can get here x of n minus 1. Finally, we can get the output as your x of n minus 1 into y of n minus 1 plus 0.5 into x of n. Next is your recursive and non-recursive systems. Recursive means output y of n depends on present and past inputs as well as past output. Y of n is equal to summation k is equal to 0 to m n into x of k. Non-recursive means output y of n depends on present and past inputs. When we giving the input to your x of n, that can be multiplied with your y of n minus 1, we can get the non-recursive systems. Y of n is equal to summation k is equal to 0 to m h of k into x of n minus k. Next one, we can see the Z transform. Z transform is used for analysis of discrete time signals. It is more broad compared to discrete time Fourier transform. It is very useful in discrete time systems as well as system analysis. X of n and x of z forms the Z transform pair. When we giving the x of n pair with Z transform of x of n is nothing but your x of z. X of n and x of z is called as Z transform pair. This is the ROC of your Z transform. Next one, linear time invariant discrete time system. First, we can see the system transfer function, that is nothing but your ratio of the output to the input. H of z is equal to y of z divided by x of z. In terms of frequency response, the z can be replaced by omega. H of omega is equal to y of omega divided by x of omega. Next one, condition for an LTI, linear time invariant system to be causal. H of n is equal to 0 for n less than 0. Linear time invariant system to be stable. Summation k is equal to minus infinite to plus infinite. Modulus of h of k should be less than infinite. This is the Z transform of your unit circle ROC, where while we taking the x-axis and y-axis of the unit circle, a less than 1 means it should be lesser than 1. The shaded portion will be lesser than 1. A should be greater than 1 means it should be greater. Outside of the circle is nothing but your a greater than 1. 1 divided by a greater than 1, the inner portion of the two circles should be shaded, and then 1 divided by a less than 1 means it should be the inner circle should be shaded. Next is your, this is the ROC of Z transform. H of Z, x of z is equal to z divided by z minus a, which can represent your modulus of z should be greater than a. When we giving a real part and imaginary part, a can be given as a circle means z, the outside of the circle will be shaded. When x of z is equal to z divided by z minus a means modulus of z should be less than. The a can be indicated by your arrow mark. The inner portion of the circle will be shaded. Next, how to find the impulse response? First, we can, for the difference equation, we are applying the Z transform and then applying, then solve we are taking the algebraic equation and solving for the roots, and finally we can taking the inverse Z transform, we can get the impulse response as your H of n. This is the basic discrete time signals which we represented. First one is unit step signal. U of n is equal to 1 for n greater than or equal to 0, 0 for n less than 0. This is the graphical representation of unit step signal. It is an amplitude of 1 for all the positive values of independent variables. Del of n, that is unit impulse signal, can be defined as del of n is equal to 1 for n is equal to 0, 0 for n should be not equal to 0. R of n is nothing but your unit ramp signal. It is a linearly growing function. It can be defined as n for n greater than or equal to 0, 0 for n less than 0. It is a linearly growing function. Next one, pole zero plot of linear time invariant discrete time system. Zeros means the value of z where p of z is equal to 0. The complex frequencies that makes the overall gain of the filter transfer function should be 0. Pole means the value of z where q of z is equal to 0. The complex frequency that makes the overall gain of the filter transfer function is infinite. X of z is equal to p of z divided by q of z. This is the representation of the pole zero plot. Next one, how to solve the linear difference equation by using Z transform. By applying the shifting property of unilateral Z transform, we can getting the solving difference equation. Y of n minus 1 par with Z inverse of y of z plus z into y of minus 1. Y of n minus 2 means z par minus 2 into y of z plus z inverse of y of minus 1 plus z of y of minus 2. Y of n minus 3 means z par minus 3 into y of z plus z par minus 2 into y of minus 1 plus z inverse of y of minus 2 plus z into y of minus 3. Next one, how to find the Z transform of X of n into U of n means, first we can applying the X of Z formula, summation n is equal to minus infinite to plus infinite X of n into Z par minus n. U of n condition means 1 for n greater than or equal to 0, 0 for n less than 0. Now we apply as your limit from your 0 to infinite 1 into Z par minus n. We can get it as 1 plus 1 by Z plus 1 by Z par 2 plus 1 by Z par 3. 1 plus a square is equal to 1 divided by 1 minus a. We can get it as your x of z is equal to z divided by z minus 1. While we taking the for z transform of del of n function means whatever the transform of del of n, we can get the value as here 1. X of z del of n condition means 1 for n is equal to 0, 0 for n should be not equal to 0. Finally, the unit sample response of Z transform of unit sample function is x of z is equal to 1. Next, how to find the y when the given function, difference equation of the given function. Y of n is equal to 2 into 1 by 3 par n into u of n and x of n is equal to u of n. How to find the impulse response? First, we can taking the Z transform for y of n and x of n. We can get y of z is equal to 2 into z divided by z minus 1 by 3. X of z is equal to z divided by z minus 1. Now we can take y of z divided by x of z. Therefore, h of z by z is equal to a divided by z plus b divided by z minus 1 by 3. While we applying the value, we can get solving for roots which is equal to a is equal to 6, b is equal to minus 4. Finally, we can multiply with your z. We can get the function as h of n is equal to z by z1. By z transform of 1 is nothing but your del of function. 6 into del of n minus 4 into 1 by 3 par n into u of n. Next is your linear time invariant discrete time system transfer function. How to get your system transfer function? First, for your given difference equation, we can get taking the Z transform, we can get the system transfer function. Y of n is equal to 7 into y of n minus 1 minus 12 into y of n minus 2 plus 2 into x of n minus x of n minus 2. While we taking the Z transform on both sides, we can get y of z is equal to 1 minus 7 z inverse plus 12 z par minus 2, which is equal to x of z into 2 minus z par minus 2. H of z is equal to y of z divided by x of z, 2 minus z par minus 2 divided by 1 minus 7 z inverse plus 12 into z par minus 2. Next we can see the applications of Z transform. It is used to analysis of discrete time systems. It is used for digital signals. It is used to solve difference equation with constant coefficients, to characterize the transfer function of a discrete time LTI system, to design a digital filter. First one, difference equation. Difference equation means it is used for analysis of your linear time invariant discrete time system. That is, y of n is equal to x of n into h of n. What is mean by Z transform? Z transform is used for analysis of discrete time signals. X of z is equal to summation n is equal to minus infinite to plus infinite x of n into z power minus n. Define system transfer function of a linear time invariant discrete time system. H of z is equal to y of z divided by x of z. That is ratio of output to the input. Name the condition of linear time invariant discrete time system to be causal and stable. Causal means h of n is equal to 0 for n less than 0. Stable means summation k is equal to minus infinite to plus infinite. H modulus of h of k should be less than infinite. Mention the tips to find the impulse response of the linear time invariant discrete time system. For the given difference equation, we can applying the Z transform. We can taking the algebraic equation, solving for roots. Finally, we can apply the inverse Z transform. We can get the impulse response of linear time invariant discrete time systems. Define FIR and IIR systems. The length of the impulse response is finite in FIR systems. The length of the impulse response is infinite in IIR systems. Z transform of unit step function is x of z is equal to z divided by z minus 1. List the applications of Z transform. It is used for analysis of discrete time signals. It is used in digital signals. To design a digital filter. It is also to find the difference equation with constant coefficients. Thank you.